This lecture will go more into depth on the design of the infrastructure and network of Hyperloop. At the end of this lecture, you will be able to provide a first design of a Hyperloop network and explain why such a network needs to be chosen. In general, the study for a new mode of transportation is started with an analysis of the existing transportation system. In such a study, the different modes of transportation are identified, and more importantly, it is studied for which type of travels the different modes are used. Within this framework, it can be seen that people bike or walk in the lowest layer of our network. This is only used for small distance traveling. Cars and public transport are used for medium-long distance travel. This is usually between a few kilometers to a few hundred kilometers. The highest layer in our network consists of travel by aviation and high-speed rail. These modes are used for international and intercontinental travel. An evaluation of transportation was already done at the start of this MOOC. Shortcomings in modern-day transport were congestion, pollution, low reliability, and high maintenance costs. When examining these shortcomings on the different modes of transportation, it is shown that the highest leap in quality can be achieved in mostly continental aviation. This type of travel is very polluting and emits lots of noise. Moreover, the user experience is not optimal, as the waiting times at airports are relatively long. In this sense, Hyperloop is ought to make the largest contribution to society by partially taking over demand for continental aviation. The fact Hyperloop fits continental aviation best can also be concluded from an economic perspective. Without getting into too much detail, the costs for Hyperloop infrastructure are now estimated to be around 40 to 50 million euros per kilometer, also taking into account potential underground infrastructure of Hyperloop. Considering the demand for continental aviation nowadays, Hyperloop can be profitable by charging around 32 cents per kilometer for a ticket. This price is comparable to continental aviation and high-speed rail. In this sense, Hyperloop will accommodate what is called incidental travel. This means Hyperloop will be used for business trips, tourism, and perhaps even regular commuting. However, this normal commuting is currently not the main objective for Hyperloop. The ticket price also means that Hyperloop will most likely not solely be built for the transportation of goods, as the value of time of goods is too low to transport it against the higher costs of Hyperloop. Hyperloop will, however, also be made suitable to transport high-value goods, such as medicines and perishables. Now that these figures are known, a first network design can be started. Network design starts with the selection of hubs that need to be connected through Hyperloop. As said, Hyperloop will mostly focus on passenger transport. Considering the continent of Europe, Hyperloop works best when the larger population hubs are connected. This means that cities like London, Brussels, Frankfurt, Paris, Amsterdam and Berlin should be included in the Hyperloop network. Now that the selection of hubs has been performed, it is the task to connect these hubs in the most efficient way. The most efficient way in this case means that profitability should be maximized. This can be done by a networking algorithm. The following steps will be performed in this algorithm. Step 1 consists of the input of the economic parameters. Here the costs and ticket price for Hyperloop and its infrastructure are determined. Step 2 comprises of the input of the hubs and the distance by which they are separated, taking into account potential detours to avoid difficult geological conditions like mountains. In step 3, the connectivity matrix is built. This matrix contains information of which cities are directly connected with each other and which are not. For example, it makes sense to connect Amsterdam and to Brussels and then Brussels to Paris, instead of connecting Amsterdam to Paris and Brussels to Paris separately. In step 4, the travel times between all of the cities are calculated. The shortest path algorithm can be used here. In the next step, a so-called gravity model is used to determine the amount of travels between all of the cities over the network. Input for this are the travel times between the hubs and the population number of each city. Finally, from the number of displacements between each city, the total profitability of the network can be calculated. Note that the model used here does not take into account the so-called modal split. The modal split contains information on which mode of transportation is preferred by travelers. Since the modal split of Hyperloop is not yet known, it is not considered in this first network design. This concludes our lecture on the Hyperloop network. You have learned which aspects are influencing the design of our network, what the approximate cost is, and again, which problems we have in transportation today.